Hello everyone, InfoSec Gurung here, and we'll start with step 17. In the previous video, we saw that we have completely enabled raw mode whenever our text editor, which is kilo, starts executing in our command line interface, which is in the terminal. Okay, now what we'll do is it's time for error handling, and now we need to clean up the code by adding some error handling. What error handling will allow us is, like, if our kilo fails to execute due to some issue, we'll get to know what that issue is. Okay, now we'll add a die function with that prints an error message and exits the program. Okay, so this is the die function. Since it's void, it doesn't return anything. It has a constant character star s asterisk s, which is the pointer. Okay, then there is a function called perror in which we pass the character s, the address of it, into this, and then we are exiting with exit 0, which is the system call, right? Okay, we'll just check if it's the system call or not. Okay, causing the shell to exit, that's fine. The standard error shall be used for diagnostic messages. Okay, so the exit utility shall cause the shell to exit from its current execution environment. Cool. So that's that. Let's just check wherever it's present. Terminate the calling process, terminate a process, terminate the calling process. Let's just check in the second page. Yeah, terminate the calling process. So it's included in uni stdi uni std.h. Okay, and this is the function we're looking for. Okay, so no return void exit in status. The status describes us the code due to like 0 is normally exiting, and 1 is like if any error is there. Okay, so exit function terminates the calling process immediately. Any open file descriptors belonging to the process are closed. Any children of the process are inherited by init. Okay, that's fine. Cool. So these functions do not return. Now you can go ahead and read, but that's it, like the information for what I want. So see, there's termios also, which we can see. Then there's for, kill, wait. That's all in that's all a part of the operating system, like the subject. Okay, and we can exit. We need to add void die. Okay, void die. This is a constant character asterisk s, and then we'll be having a perror function which returns which has an argument of s, and it will exit 1. Okay, just a minute. I think, yeah, that's fine. We'll make kilo. Yeah, and now let's just see how it executes. Okay, so yeah, in the previous video it's following the whatever we did in the previous video, the experimentation. Let's just fix our kilo. Okay, so we need to go to the 32 page and have 1 for this, and that's 0. Okay, that's fine. And here we need to have the \0, which is the null character. Okay, now it's fine. Let's just check it once. This is fine, 0 and 1. Okay, fine. Now p error comes from stdioh, and exit function comes from stdlib.h. Okay, so this compiles but with no observable effects. Most C library functions that fail will set a global or no variable to indicate what that error was. P error looks at the global error no value. I think it's error number. Okay, error number variable, and prints a descriptive error message for it. Let's just see. Man error no number of last error. It's present in errno.h. Okay, so the error no defines a integer variable erno, which is the error number, which is set by system calls and some library functions in the event of an error to indicate what went wrong. Yeah, so the value of error no is significant only when the return value of the call indicated an error that is -1 from most system calls. Okay, then that's fine. So these are the list of error names. It's a pretty vast list. Cool. Looks at the global error no variable and prints a descriptive error message for it. Okay, it also prints the string given to it before it prints the error message. It also prints the string given to it before it prints the error message, which is meant to provide context about what part of your code caused the error. After printing out the error message, we exit the program with an exit state of 1, which indicates failure, as would any non-zero value. Yeah, so 0 means success and -1 or 1 means failure. Okay, and we'll just try running kilo. Okay, first we need to compile. Cool. Yeah, so it's working how it was intended, like at step 16. Yeah, so we'll exit kilo, and this is our step 17. We'll check the notes for this. So die function prints the that's fine from error no, which is the last number of last error. Okay, after scrolling more on this manual for error number, we find the different values set for different errors. That's fine. Okay, let's just search for p error. Explains errors codes. For most system errors, MariaDB displays, in addition to an internal text message, the system error code in one of the following styles. Okay, so there's message. Okay, and then we'll get to know, since p error prints a descriptive message for a system error code, then we'll get to know more about the error. Okay, that's fine. So option 13 and error code 64 says permission denied and machine is not on the network. Okay, so yeah, you can read more about this. Fine. So whenever you have doubts, like whatever is used in the tutorial, you can just use the man pages to know more about it. And one handy thing which will come in use is the -k option. Okay, and yeah, that's quite helpful, because if you see in the beginning, I had used like man exit. Okay, so this is not what we are using. This is for the bash shell. Okay, and it's in 1p, which is the section. Okay, so you can just see man -k and exit. So this man -k exit tells you like wherever the word exit is used in the title or in the description, it will show you all those options. Okay, so what we were searching for was this one. That's why I had to type man 2 and exit. So 2 is the section number. Fine. Yeah, and that's it for this video. We'll be next looking at step 18, and we'll be again continuing with our error handling. Okay.